Okay, we're recording. Okay, so again, you don't even have to write this down. Unless, do you still have some of that graph paper I gave you? You don't have to write it down, but can you make a quick sketch of what that looks like? What does y equals 2/3 x minus 3 look like? So before we kind of get into chapter 5 review, let's do one last grade 9 review. Because you know the chapter 5 here in grade 10 just assumes you already know how to graph a line. So do you remember our little lessons that we did together where we graphed lines? Our grade 9 review. Make me a sketch of that. If you don't have any graph paper left, just do it on loose leaf and draw yourself a grid. Go 6 up, 6 down, and you don't even have to go 10 across, but you know what I mean by draw a graph? Okay, so draw a graph. Make that line. Don't wait for me to draw it for you. Give it a try yourself. The worst you can be is wrong. Okay, so I'm going to go over to the. Okay, I've got my eyes on the chat. If anybody at home has any questions, you can ask me. But I'll give you a sec to graph this. This shouldn't take long. We've done quite a bit of practice on this. You should be able to do this 30 seconds or less. Use loose leaf. Doesn't matter. You don't have loose leaf either? Okay, then help yourself to a piece of that graph paper right there. Hurry up. Dude, you got to show up with stuff to write on. Just tear off a piece. There you go. All right. Most people have their pencils down already. This should go fast, right? In grade 7, you graph lines like this by making a table of values. Probably most of you in grade 8 too. Grade 9, hopefully you're past that. And certainly now by grade 10, you're past this. You know this is your y-intercept. And you know that this is your rise over run. So from that point, go up 2 and over 1, 2, 3. And if you want, if 2 points isn't enough for you to make a line, go up 2 and over 1, 2, 3. And then use your fancy graphing software to make a line. Oh, it's terrible. Undo, undo, undo it. I'll try one more time. And then I'll give up and just draw a line. Yeah, that one's better. I'm pretty happy with that one. What do you think? All right, so as you can see, I copied this page off of the online grapher. So if I were to go to the online grapher, how close do you think we are? Do you think that's going to look good? I'll give you a little insight to how I do things. When I mark tests, you know what I actually like to do is I go down to the photocopier and I photocopy my answer key onto a one of those clear pieces of plastic like they used to use for overhead projectors. Because, you know, schools don't use overhead projectors, so there's probably a million of those old sheets just sitting around that nobody uses anymore. So I'll photocopy the answer key onto an overhead projector, and then when I mark your work, I'll just sort of slap it on top, see if your line's correct. Should be very close to what I have here. So let's see. Desmo says, well, that's my blog. Desmo says, there it is. Is that your line? I think that looks pretty close to what I had. Yep, bang on. Beautiful. Okay, now, is this any different? Will this line look different than that line when I click the button? I'm asking you. People are shaking their heads no. They are correct. All that I've done to turn this into this is I've written it in, what is this called? Function notation. Very good. So this is function notation. Watch, I'll click on it. All that's going to happen is the line changes color because it's the same line. Now, is this the same line? 2/3 times x, or 2 times x divided by 3. What do you think? Oh, okay. What's your question?
You know, like the -3 in the exposition?
Yep.
So that's always going to be the y coordinate?
That's right. Y equals mx plus b. So as long as you're in that form, you have this number, x, then this number. As long as you're in that order of the equation, then this number is always your y-intercept, and this number here, can you see where I'm pointing, is always your slope. Okay, always. And you know what else I was going to do? I was going to say, okay, what if we just started with this question, and I'd have said, hey, tell me what the slope is. Suppose I didn't know that number. And you'd look, okay, you could go, oh, well, I rise 2 when I run 3. Get it? 2 divided by 3, right there. What if I didn't know this point and I just knew this one and this one? Then I'm rising 4 and I'm running 6. What's 4 over 6 simplify to? 2 over 3. That's what makes it linear, is that slope will always be the same number, no matter how far apart the points are along the line, right? So that's the same thing. Okay, going back to Desmos, and back to my question. Is this third version here the same thing? What do you think? I haven't had an opinion yet from the people in the room. How about people at home? When I turn on that, am I going to get the same line? I'm getting a few people shaking their heads yes, and a few people shaking their heads no. I have dissension amongst the ranks here. What do you think? Check it out. It's green, it's blue, it's green, it's blue. Timesing a number by 2, then dividing it by 3 is the exact same thing as timesing it by 2/3. Think about why that's true. And that's the kind of thing you should be able to understand when you look at these equations. Okay, so for my next equation, we'll do another one here. Graph me that one. Y equals negative 2x plus 5. And again, this should take 30 seconds or less. And the first person who's done could get up, please, and close the door, because I don't know what they're doing out there, but it's very noisy. Thank you very much. Much better. Thank you. All right. Anybody need more time to graph that line? We good? Plus 5 is up here. And okay, what's the rise over run? There might be people saying, hey, they didn't give us a run because it doesn't have a bottom. Yes, it does. Negative 2 is the fraction, negative 2 over 1. So it goes down 2 and over 1. So I guess I didn't need to put a point there. Down 2 and over 1. Down 2 and over 1. There's my line. I think this time I'm just going to freehand it. Oh, okay, pretend that's a straight line, would you? There, I made a bigger dot. And there we have it. Let's see. How close is this to what Desmos would say? I think it's going to be bang on. Let me get rid of this guy. Okay, except that mine's crooked. It's in the right place. Everything's good. Is that what you got? Okay, take a look at this. Remember that when you actually make a function, a linear relation that is representing something in the real world, you don't always use x and y. You might use variables that represent the first letter of the words of the variables you're measuring. Like, for example, maybe the equation was, I run a business that's online, and I make $5 every transaction, but people online are extremely impatient. If there's any sort of glitch that slows down, I lose $2 of profit for every second that my program lags. So it's a $5 profit, but I lose $2 every second. So T is time in seconds, P is profit in dollars. But notice that's exactly the same line. Doesn't matter what letters you use, as long as that's your, what do you call this variable again? Begins with an I? Independent. And then the P would be the dependent. And the independent always goes on the x-axis, no matter what letter you use. And the dependent always goes on the y-axis, no matter what letter you use. Okay? And please notice, negative 2 plus 5 is the same as 5 minus 2. Right? So the fact that I rearranged the order did not change the fact that it's the same exact graph. Okay, let's go backwards now. What if I gave you this graph? You don't have to draw it, just look at it. and tell me, first of all, what equation this line is. What equation would make that line? Here, why don't I look at it on here? There it is. So, give you a sec. Go backwards now. Find me a slope, find me the y-intercept, and give me the y equals mx plus b. Okay, was that enough time? So I know that the equation, because it's linear, looks like this. So basically I have to fill in these two blanks. What's the b blank? Looks like it's -3. So y equals something x minus 3. What goes in this blank? Pick 2 points that you can totally definitely read. How about that point there, which looks to me like it's what is that? That's 4 over and 0 down. And then how about that point there? And say that my rise, how much am I rising there? -3. It's going down, so you got to say negative. And how much are we running? So I think it's -3/4. Agreed? And there might be people going, well, wait a minute, I just used the dots they gave me. And I counted all the way down to here. That was a rise of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, wait a minute, I think I just counted that wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I guess it is 10. Oh, yeah, but you know what? I wouldn't use this point. Because look at it. Yeah, it's like a 0.5 or a 0.6 or something. Meh. You know what? We'll deal with that in a minute. We'll get to you in a minute. I'd use this point. How about that? So from here down to here, that's clearly 9. And, oh, sorry, -9. And from here over to here, clearly that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I didn't get -3/4, Mr. K. I used those 2 points, and I got -9/12. And I think everybody who passed grade 7 math should realize that these two numbers are exactly the same number and should be able to turn that number into that number. And if you can't, who let you out of grade 7? What were they thinking? Okay, not a big deal. If you're one of those people that you forget to reduce your fractions, simplify your fractions, it'll cost you half a mark. Okay, but get used to looking at all your fractions and asking yourself, oh, can I simplify that? Okay, because that's going to come up over and over and over again in math. All right, so that's that one. Let me erase all these extra lines I put on here. And let's review some other things we did this unit. Notice that this one doesn't have arrows at the end. It stops and it ends and it starts again and it ends. And what's its domain? Okay, so quickly write down your domain. I'll do it over here. Oh, here. I'll move over. Oh, I learned a new trick today. Ha! It saves me a lot of erasing time. So what do you think the domain is? Look at the dots. Can you see the dots from where you're sitting? Should I zoom in on the dots? Zoom in on the dots. And zoom in on the dots. You got an answer? X is greater than or equal to -9, but it's less than or equal. Oh, wait a minute. Is it equal? No, because this is an open dot. So it's less than 4. Now, how about range? I'll give you a sec. Try range. Range has a problem. Range has a slight issue. that we're going to have to deal with. See if you can figure it out. You know what the slight issue is, right? Zoom in again. Oh yeah, that doesn't make it all the way up to 4. Maybe it's 4 point something. If only I had a way to figure out what that y number is. I'll let you think about it for a sec. What was my equation again? Y equals -3/4 x minus 3. Was that right? Okay. You know what I would like to know? Well, let's see. Range is y, correct? And I clearly, the smallest number y can be is right here, but it can't actually be that number because it's an open dot. So greater than -6. It can get to this number, so it's less than or equal to, but the problem is I don't know exactly what that number is. But I could find you that number if I could answer that question, this question right here. Do you get why the answer to this question is this number? Because I'm asking you how much is, or I could ask you this question. Maybe a what would be better than a how. What is the range value when the domain value is -9? Right? So how do you do that? And so you could try to read it off the graph, but again, well, it's somewhere between the grid lines, so that's kind of hard to see. Right? Again, zoom in. What do you think? Got a guess? 1, 2, 3 point something, not quite 4. I don't want to guess. I don't want an estimate. I want to know exactly. I can find exactly because I can answer this question using my algebra skills. F of -9 means plug -9 into this function. Could we have a calculator for that, Mr. Kello? No, you can't have a calculator for that. You should be able to work with basic fractions and stuff. Okay, so what would you get? Well, remember when you multiply a fraction by a whole number, you just go top times top, bottom times bottom, but remember, a whole number has a bottom that's equal to 1, right? That's my invisible 1 down there. -3 times 9 is 27. 4 times 1 is 4. I have to treat this 3 as having a 1 for a denominator. And what's the common denominator of 4 and 1? 4. So I have 27 fourths minus 12 fourths is equal to 15 fourths. So I'm happy with that. You could give me that number. You could give me that answer. That'd be a perfectly good answer. Here, let me erase the box. Oops, that's not my eraser. 15 fourths would be good. Or, you like decimals better? Fine, you can have decimals. What decimal is that? It's 3.75. It's 3 3/4. You could go with mixed numbers too if you want. Mr. Kello, could I have done this using decimals instead of fractions because my fraction skills are bad? Sure. I'll be a sport. You want to change -3/4 to -0.75, and then you actually want to take the time in your life to go, what's 0.75 times 9? And then work with that? It's not that hard, right? You just have to break out what's 75 times 9. That's 45. Watch me goof this up now, because I never do this. 63, 60, 67, but it was a 0.75, so there's a decimal there. So that's, oh, see, I did something wrong. That's a 4, isn't it? Why did I write down a 4 here? I said 45, but I wrote down 44. See, I told you I was going to mess it up. So this is 6.75 minus 3, 3.75. I don't know. You decimal fans, you fraction haters, you really want to tell me that's simpler without a calculator than this? I don't know. There's people nodding yes. People love decimals. I don't know what it is, man. I got bad news for you, though. The further you go into high school and pre-calculus especially, the less and less decimals you're going to see. We tend to do most things with fractions. So if your fraction skills are rusty, you should work on that. But anyway, 3 3/4 was the right thing. Somebody guessed it at home right off the bat when they were just looking at it. And I know why you were thinking that, too. You're probably thinking, well, this is halfway, and this looks like it's half of half, which is a quarter. Is that what you were thinking, person who guessed 3 3/4? That was a good guess. Nice job. But we can do better than guessing because we know how to use our algebra to find us functions and their values. Okay? So there we go. So we've seen domain, range, function notation. Let's do one more. First of all, is this linear? Right away, people are going, no, that is very clearly not a straight line. Is it a function? You're shaking your head, yes. Why do you know it's a function? Every x has a unique y. It passes the vertical line test. Every vertical line I could draw through here only hits the function once. Right? Every x has a unique y. So we're cool with that. So let's see. Let me go back and go back. Okay? So it's not linear. It is a function. I think, can I make you come up with the equation for this one? I'm afraid not. In grade 11 we will. Grade 10 we tend to focus algebraically just on the linear stuff, but you should still know the difference between linear and not. This is clearly not. And you should still be able to tell me domain and range. So I'll give you a sec, see if you can figure out its domain and range. Can you see the difference between the two dots from where you're sitting? This guy's solid. This guy's open. All right, go for it. Tell me domain and range. I'll give you a sec. Notice that they all have to look like this at some point. Pretty much all of them anyway. All I'm doing now is filling in these spaces here, right? I need to know what this number is, and this number is, and this number is, and this number is. Oh, and I need to know if I should put anything underneath those less than symbols. So really, at the end of the day, that's all you have to do is fill in those 4 blanks. Everything else is always the same. Usually. Will we get marked on the curly brackets? If you don't give me the curly brackets, or at least attempt to give me the curly brackets, then yeah, you're going to lose half a mark. Your notation is wrong. Those curly brackets are expressing that I am showing you what set of numbers the domain belongs to. So yes, this is the way mathematicians talk. This is the way they write. This is the language you have to get used to seeing. Will I take off half a mark if your curly brackets are ugly? Well, considering the monstrosity that I've just put on the page over here, I don't think I can hold it against you if your curly brackets are a little bit oogly. I've been drawing them for 40 years and I'm still not good at it, so as long as you make the attempt at a curly bracket, I won't complain. All right, so you got an answer? X is bigger than -2. Whoops, I'm still in the highlighter, sorry. X is bigger than -2. Could it be equal? No, that's an open dot, so don't put an equals on that one. X could be smaller than or equal to, what number do we have here? What is this value for the X? 2, 4, which makes that 3, and it makes this, I think we're looking at 3.5. Here, we'll make you decimal fans happy. We'll go with the decimal. All right, now for the y values, well, because I didn't have an equation for this one, I'm probably going to have to guess at this point. Oh, wait a minute. Does this point matter for the range? No, it doesn't. Why doesn't that point matter for the range? Because the range goes from the smallest y to the biggest y. So y is bigger than or equal to that dot right there. What is that dot? Looks to me like it's -4. And y is smaller, but not equal, because of the open dot, to 4.5, 5. Is that what you got? Then you got it right. Did anybody fall for this and try to find that for their domain for their range number? That is not part of the range number. Okay, one last thing, and then maybe I'll let you guys get going. Oh, maybe two last things. Hang on. Oops, 5. Two last things. Could you please tell me what the x and y intercepts are in this graph? I'll give you a sec to think about it. You don't have an equation to look from, so you're just going to have to read them off the graph. I'll give you a hint. It has 2 x-intercepts, but it only has 1 y-intercept. Okay? Who wants to tell me? What's the x-intercepts? What do you think? I agree. -1 and 3. Now, you want to see how mean I have to be when I mark your test? This is how mean they make me. When you go to math teacher school, they train you on how to be mean. If you did that, I have to take off half a mark. Can you explain why? Because now, by putting those brackets around it, you've made it so that I think that you think those are coordinates, in which case this would be the x-coordinate and the y-coordinate. But that's not what you mean. You have 2 x-coordinates, one's -1 and one's 3. Don't put a bracket around it because that doesn't make sense. That wouldn't be how you'd say 2 x-coordinate numbers, right? Does that make sense? I don't think I mentioned that when we did that lesson, so hopefully that makes sense to you. All right, what are your y-intercepts? Oh, sorry, there's only one of them. What do you think? -3? All right. And one last thing. Go back to domain and range. What would change if instead of this being an open dot, what if it was an arrow? So let me play with my new toy again. Haha, that's so cool. What's my domain and range now? I'll get you. I'll give you a sec to think about that. Seconds up. What's my domain? Well, what's the smallest thing x can be? X can get smaller forever. That arrow means it keeps going. So the biggest thing x can be is this 3.5. So I'd say x is less than or equal to -3/2. And yeah, you should probably still put that in a curvy bracket. What about your range? What are you thinking for range? Oh, why did I say negative? Thank you. You're more awake than I am. Nice job. This is not a negative number. Thank you. That was a mistake. That cost me half a mark. All right. Clearly, I can't be trusted. Can somebody tell me the range? What does this arrow change about the game? Is there a limit to how big y can be? No, it's going up forever. So y is bigger than or equal to -4. All right. And then What would change about domain and range? Oop, oh, hang on. I hit the button wrong. What would change about domain and range if there was arrows on both sides? Now what? What would you say for domain? What are you thinking? You can say that X can be any number you can think of, right? Because it's opening forever. Everywhere there's an X number, and you say that by saying X is an element of the reals. Is that true for Y? Well, I'm afraid Y can't be -5 or -6 or -1 billion. It doesn't go any lower than this, so this one actually doesn't change. Y is greater than or equal to -4. Okay, that was a very quick little review of most of the stuff we did, say from 5.3 on. 5.1 and 5.2 was the stuff about just learning what a function means and arrow diagrams and data tables. So that stuff's in the review. This stuff's in the review too. So I'll give you some work time now. Guys at home, if you want to turn off the computer and just work on your own, you can. I'll leave the meeting open in case anybody has any questions. I'll also post this video. Thanks for watching the video.